We are now going to look at solving quadratic equations by graphing. So let's look at those first three words, solving quadratic equations. Earlier this year and in prior math classes, you knew how to solve linear equations when it was a to the first power or x to the first power. And we had a pretty set step-by-step process in order to solve that. We would first eliminate any parentheses using the distributive property. We would then look to combine like terms. Then we would get our variables to one side and then use inverse operations to isolate the variable. It was pretty routine in our step-by-step process. When we solve quadratics, it's not as routine because each quadratic is different and unique. And we're going to learn multiple methods for solving quadratics, the first of which is graphing. So let's look at the definition of quadratic roots. What is meant by a quadratic root? Well, it's where the graph crosses our x-axis. So let's write that out in definition. So we're going to say the point or points, there could be more than one, where the parabola our quadratics are always parabola intersect the x-axis. Roots is one of the words we use to describe that. We also have some other words that are synonyms for roots. Zeros, solutions, and what we had called them prior, x-intercepts. So all four of these words, roots, zeros, solutions, and x-intercepts, all mean the same thing. It's the point or points where my parabola crosses the x-axis. When we solved linear equations, okay, when we were looking at solving for a, we might have gotten a solution. Sometimes we got no solution. Sometimes we got all real numbers, so we had some options. Well, with quadratics, we might have two solutions, one solution, or no solutions. Those are our only three options when we're solving quadratics. So what might the graph look like if my quadratic has two solutions? Well, my solutions are where the parabola intersects the x-axis. So I'm going to have a parabola that crosses my x-axis in 2 points. It might be a parabola that opens up or a parabola that opens down. It doesn't matter, but it's crossing my x-axis in 2 places. So those x values would be my solutions. If my quadratic has one solution, that means it's just crossing my x-axis once. It, again, could be a parabola that opens up or down. I'll do an example of one that opens down here. It's just going to touch my x-axis, therefore giving me one solution. No solution means my parabola isn't going to touch my x-axis at all. So it might look like this, or it very well could look like that, as long as it's not crossing my x-axis at all. Let's look at these examples. It says, find the solutions of the following quadratic equations by graphing. And so we're going to let you guys use Desmos in order to find these solutions. So let's look at number 4. Y equals x squared plus 4x minus 5. Y equals x squared plus 4x minus 5. So I'm interested in the points where my graph crosses the x-axis. Okay? That's where my y value is 0. What can I put in for x on my quadratic that will make y equal to 0? I can see I have the coordinates -5, 0. So if I put -5 in for x, my output will be 0 for y. And also if I put 1 in for x, my output would be 0. So -5 and 1. So x equals -5 and x equals +1 are my solutions. Select pause and work through questions 5 and 6. On your graph for number 5, you saw that it was a parabola that opened up and it just touched the x-axis at x equals 1. Number 6, it was a parabola that opened down and it did not cross the x-axis. Therefore, it has no solution. As you recall, the 0 with a slash through it is our symbol for no solution. So there are no values that I can put in for x that would ever make that equal to 0. When we're looking at a graph, it's easy to determine the number of solutions, either 2, 1, or 0, based on the number of times it crosses the x-axis. But let's look at another way I can find the number of solutions. It is using what we call the discriminant. Okay? Let's first define discriminant. The discriminant is used to determine the number of solutions. So we don't always have a fancy way of pulling up Desmos and looking at a graph. Okay, that won't always be within our capabilities. So we have to look at another way. So if I'm looking at an equation and I want to know how many solutions there are, I'm going to use something called the discriminant. We have a formula for it. So to find the discriminant, we're going to take our b value squared, subtract 4 times a times c. So we're using the a, b, and c values that we talked about when we looked at standard form of a parabola. If my d value is greater than 0, so if after I do the math I get a positive number, that means there are 2 solutions. If after I do the math and I find that my d value is equal to 0, there are 1 solutions. If my d value is less than 0, there are no solutions, 0 solutions. So let's look at number 7. Y equals x squared plus 5x plus 4. Oops. My a value is 1. My b value is 5. And my c value is 4. So let's plug it in our equation. D equals my b value squared minus 4 times my a value times my c value. Order of operations, 5 squared is 25. And then I'm going to subtract 4 times 1 times 4 is 16. 25 subtract 16 is 9. Because 9 is greater than 0, that means that there are 2 solutions. Let's look at number 8 together. Our a value is 1. B value is -3. C value is 10. Let's plug it into our formula. D is equal to my b value squared, subtract 4 times a times c. Negative 3 squared is 9. 4 times 1 times 10 is 40. Well, when I take 9, subtract 40, that definitely isn't going to give me a positive number, so I know it's negative. Okay, it happens to be negative 31, which means there are 0 solutions. Select pause to work through the next 4. As you can see, number 9 had 1 solution. Number 10 had 2 solutions. Number 11 had 1 solution. And number 12 had 0 solutions. Being able to determine the discriminant will help us determine which method for solving quadratics is easier. For right now, we're just focusing on solving by graphing.